Alright, good day guys, how are you all doing? We're talking about ordinary differential equation, and there's a lot of things fascinating about this differential equation. Now you see, we call it differential equation, or we say O.D.E, as an equation that contains a differential coefficient. Are you with me? And we have different categories in terms of their order. So at times they call it a differential equation because of the orders they have. They could say ordinary differential equation, or we say the orders of the differential equation. So you have first orders, you have second order, you have the rest like that. Now, how do you know the orders you have to classify them as? You have to classify them based on the highest differential. Are you get what I'm saying? That occur in them. So differential equation links to differential coefficients, but classification of them is based on their highest differential. So when I tell you that I have something like a y prime equals to maybe 6x, and also let me say I have something like this, a double y prime plus 5 differentiating the y prime plus 2y equals to 0. Now if I want to put it on the orders, are you with me? This would be what you should have known. Only a single, the highest one there is 1. So I have a first order of differential equation, and I have a first order here and I have a second order here. So I'll classify based on what the second order, because that is the highest. So this is the second order of differential equation. So that is how they classify that. Now we also have what we call degrees. Now you have the degrees of a differential equation. Are you with me? And you see this degree of differential equation, it is the same thing with this, but this one times talks about power. Are you with me? So it is like the highest power, are you with me, of that differential equation. So when you want to put it now, if you want to talk about the degree, you have to make sure you are having the highest power of the differential equation. So it is not ranking based on the power, it is ranking based on the differential equation power itself, or we just say differential equation term. Like, is it first, is it second? So let's say you have something like this, raised to power 3 plus 5, let's say you have a single one here, raised to power 4 equals to 6. Now if you look at now, when you want to talk about this order and the degree is the power, and the order, these are the order. Now if I want to talk about this now, I would say that I won't pick this because of the degree. I'm picking based on the order. So this would be the highest differential equation here would be 2. Are you with me? That's the second order of the differential equation, then with a 3 degree, not a first order with 4 degree. So please note that. Okay, so we can solve differential equation by integrating. Mainly the basic part is integrating some things, that is one of the basic parts. So now also again we call something a general solution. You see, when you have solution that have more than one constant, like you have like a constant a, you have a constant b, you can have a single constant, you can have more than a single constant. You get what I'm saying? So in that kind of process, are you with me? You integrate the term, and integrating the term to get a solution, we call that kind of solution a general solution of the differential equation. Are you get what I'm saying? So from there we also have something we call boundary condition. You see, this boundary condition is very simple. Let's say you have something like y equals to mx plus c. After you've differentiated the equation, or we could say, let's say you have y equals to 3x plus c, c being the constant variable there. So when they say that, this is like a general solution to the model they give you to solve. So let's say you have this kind of thing, they will give you a boundary instead, that I can say let y, after you solve your equation finish getting the general solution, I can say let y be equals to 1 and let x be equals to 7. So this equation would later be formed as, let me just do something much more easier. Let's say let x be equals to 1, so that we can quickly get our x, and y equals to 2. So from there I sub 2 into here, and I have 3 plus c. So I could see that my constant is equals to -1. So I can write this equation back as y equals to 3x minus 1. So this is what we call a boundary condition. Now also again, your equation can occur in different categories. That's your order. You could have a particular equation which could talk about only x variable. You could also have a particular equation which could only talk about y variable, and you can have the one that will talk about the both of them. Are you with me? That's a particular equation that could talk about both the function of the x and the function of the y. Are you with me? So like this, and you see this can also be solved by integration, and some of them here can be solved by what we call separating the variable, putting x to the left hand side, putting y to the, just differentiate both of them. Let x be in one part, let y family be in one part. So we call them what we call variable separation. It is mainly common in this category. Are you with me? So that is that. Now you guys should make sure you note that what we have next is what we call how to form a differential equation. So we'll talk about how to form a differential equation, and it is actually quite easy. So if it is the first or the second, now what do I mean now? Differential equation forming depends on the constants you are being given. That's the arbitrary constants. So those arbitrary constants, if it is a single arbitrary constant, you form one single differential equation. If it is a double arbitrary constant, two arbitrary, you form a double, like that and like that. So we'll talk about 1 and 2 today, and let's say you have something like this: y equals to ax plus x squared. So this is only a single arbitrary constant, so I differentiate it once. I have a plus 2x, do not forget. Then from there, if I'm to move on, I have to make sure this is cleared. So I could say a can be equals to differentiating y minus 2x, right? So I could easily sub this into this. So you can call this equation 1, equation 2, equation 3. So I could say sub equation 3 into equation 2. That means anywhere I see a, I put y this into it. This. So I have differentiating y minus 2x, then x plus x squared, right? Then I have y equals to x, differentiating y minus 2x squared plus x squared, and I have y equals to differentiating y minus x squared. So if I'm to arrange this, I could just have this plus y equals to negative x squared, or I bring it back also. So this is my differential equation for it. So let's take another one. Let's say you have y equals to a sine, let's say a cos alpha x, then plus b sine alpha x. Sorry, do not mind my handwriting. So from there you have your differentiating y being equals to, and this is cos alpha x. Differentiating cos theta, you have negative sine theta. So take this as a theta. So you differentiate this, you have only alpha. So you have negative alpha a sine alpha x back. And this would give us what? Plus alpha b cos alpha x. So like I told you, it is two constants. So you differentiate it twice. Then the second differentiation, this sine x becomes cos x, and this also still differentiates. This will come to here, minus alpha square a, then cos alpha x plus, okay, so this becomes negative now. So we have a negative, then you have alpha square b sine alpha x, Then we could easily say that this would be equals to, look at the common variable, you have negative alpha square, then you have a cos alpha x plus b sine alpha x, which tells that all these are into a, do not forget, into y rather. So we could say that differentiating this can be equals to negative alpha square y, and you can bring it back by saying plus alpha square y equals to 0. So you have your equation. That is how you form your differential equation, breaking their variables down little by little. So let's say you have something like y equals to e raised to power minus 3x. So from here now, you have a constant, right? A single constant. So if I want to differentiate this, I could have y being equals to I have negative 3 e raised to power minus 3x. Differentiating this, do not forget, differentiating minus 3x, you have negative 3. So therefore my differentiating will be equals to minus 3, this x not y. So all this will become what? Y. So I could have this plus 3y equals to 0. So hope you can see that. So that is the differentiation values for that. So let's say you have something like y equals to a plus b e raised to power 2x. You know, differentiating this would be 2 times. You have minus 2 b e raised to power minus 2x. This will become 0. It's a constant. The second time, you are going to be having 4 b e raised to power minus 2x. So you know we have to find a way to get rid of that. And differentiating this would be equals to, so you have to find a way to put it into something like this, because this is what looks similar to it. So we can say minus 2 into bracket minus 2 b e raised to power minus 2x, because this will still give us positive 4, and that will be equals to minus 2 differentiating the first prime. So therefore differentiating plus 2 differentiating y would be equals to 0.
Now, if you look at this is a theory constant. So we differentiate it 3 times. And you have to be careful while differentiating this. So we differentiated it the first time, we differentiated it the second time, and we differentiated it the third time. Now, whenever you want to deal with something like this, you could easily use a logic. Now, you don't need to involve the first y anymore. Your issue now is between the first differentiation, the second differentiation, and the third differentiation. And as you can see, if we say the third differentiation minus the second differentiation, it would give us 4a raised to power 2x. And if we could break it down, we could say that second differentiation minus the first differentiation would give us 2ae raised to power 2x. So which we could easily say that the third differentiation minus the second differentiation can be equals to 2 into bracket the second differentiation minus the first differentiation.
About how to find the general solution. So you know, I told you guys talk about general solution. So I say general equation. So if I tell you that find the general equation of a particular differential equation that only talks about x variable, this is how you have to do it. You just integrate the both side of the variable. Are you with me? So you have your y being equals to the function being integrated for the x only, if it is only x. So let's say you have a variable like x equals to 2 minus 4x cubic. So you need to know that for every differential equation, most cases, to settle some things, you need to understand how to substitute and how to, you know, change the subject of the formula. You need to be good with that. So you know we have to make this side looks like only the y prime, and this side all the s variable. So we could divide everything by x. You have 2 minus 4s cubic over x. So this can also be written as 2 over x minus 4s cubic over x. Do not forget. So from there you can have this being equals to 2 over x minus 4x squared. So here it is now very good to you know, do our integrating. So integrating this, integrating 2 over x minus 4x squared, you know, everything are to be integrated, do not forget. And when integrating, you have a constant variable. So you have y equals to, integrating 2 over x is just like you saying integrating 2 then 1 over x. And you know, integrating 1 over x, this 2 comes to the front. So integrating, let me just put it very well, minus integrating 4x squared. So you have y being equals to 2 integrating 1 over x minus 4 integrating x squared, for those who do not quickly understand things. So integrating 1 over x, you have y being equals to 2. Integrating 1 over x will give you in x minus 4, and this will be s raised to power 3. You know the normal law, s raised to power 3 over your 3, do not forget. So this, from here you can have plus our c. So this is the general solution for it. That's if it is only dealing with the function of x. So from here, let's say you are having it dealing with only the function of y. How do you do that? Now you have to arrange it back. Are you with me? having the x in this left hand side. So you make sure you write it normal as dy dx to make it easier. So from here you have the x, then function y equals to dy when you cross multiply. So your dx would be equals to dy over your function y. So this is what we need whenever it is talking about only function y. Are you with me? So from here now, we could easily deal with anything we want to talk about. And let's still leave this aside. If we have any question under this, we'll use it to solve it. But let us talk about the important aspect also. So when you have a variable that consists of the y being equals to function x and function y, how do you tend to do that? Are you with me? So from there you have to understand something very important. This is how you do that. Write it out normal back also again. So this will be equals to function x and function y. So when you cross multiply, you have function x, function y, the x equals to the y, right? So you can divide both sides by function y. So you have function x, the x equals to the y over function y. So it's just like you having this variable separately. Okay, we call this variable separation. So you separate the variables, the s one side, the y one side, then you integrate it. So equals to integrating the y over a function of your y. Are you with me? So let's see a question under that. All these are just much like breaking down some things. When we get to the normal calculations and solving, we'll treat much more examples. So let's say you have s cubic, the x plus y plus 1 squared the y equals to 0. So from what I just said, you have to make sure that what your variables are balanced. And as you can see, this one is actually clear. It is easier to break it down easily. There are some you have to stress to break it down. So from here, you have y plus 1 squared the y equals to minus s cubic the x. So you just divide both sides by what? The x and y plus 1. You have y plus 1, then the x. Now if I were you, this won't work the way I want it to move through, because it's just like me disturbing myself again, breaking down things differently, and it won't work here. So you can easily just ignore these steps, just like I told you for the formulas. You can just put them differently in one side. Y plus 1 square the y equals to your negative s square the x. And since what you want is that they should be in separate variable, you don't have any issue breaking it down as dy dx anymore or some other things like that. Okay, so you just integrate it directly since they are already broken down. So you can integrate the y plus 1 squared the y equals to integrating our negative s square the x. Are you with me? So from here we can expand this to make it easier. You have y squared plus 2y plus 1 the y equals to, this would be integrating s squared dx. So you have this as y raised to power 3 over 3, do not forget, plus 2y raised to power 2 over 2, do not forget that also, plus y, that is the law for it. Okay, so equals to, you have this as negative s raised to power 3 over what? 3 plus your constant. So from here you have your answer being broken down. So you have your answers being broken down. Okay, it was s power 3, so let me just give you s power 3. This will be s power 4 over 4. That's the question. S power 3, do not forget, not s power 2. So s power 3. So from there you can easily break it down as s power 4 over 4 plus y raised to power 3 over 3 plus 2y squared over 2 plus y equals to c. So you have x raised to power 4 over 4 plus y raised to power 3 over 3 plus y squared plus y equals to c. So this is how you deal with it whenever you have x and y together, being clumsy. We'll talk about some crazy ones in our normal class. This is just like a basic form to explain how you can deal with them.